for everyone for joining our Zero Trust Session 3 webinar today with Ingram Micro's Emerging Business Group highlighted vendors, iBoss and Atacama. My name is Kelly Berg, Senior Marketing Manager at Ingram Micro. This webinar will last approximately 45 minutes. In terms of general housekeeping, your lines have been muted for the duration of the webinar. If you have any questions, please feel free to type your questions in the Q&A box on your screen. Thanks everyone for joining us, and now I'll hand things over to Jimmy Augustine, Ingram Micro's Chief Technology Evangelist. Jimmy, take it away.
Thank you so much, Kelly. As Kelly mentioned, my name is Jimmy Augustine, and I've been on the Emerging Business Group team for 4 years now. I want to thank you for attending today's webcast. We realize your time is very valuable. This is the third webcast that we sponsored on Zero Trust, and customer interest has been very high on this topic. Today's session is very interesting and fascinating. Today's session is going to be about secure access services, edge, and encryption. And it's a part of a multiple discipline approach to Zero Trust. But to tell you more about the Zero Trust framework, I'm going to turn it over to my good friend and partner in crime, Jerry Diedrich. Jerry, over to you.
Thanks, Jimmy, and thanks again to everybody who's participating with us today. We are really excited to present this particular series today because it really blends two key elements that are fairly new to most in cybersecurity. And what we're doing is this is part 3 in a multi-part series on Zero Trust, and we want to thank our vendor partners for participating with us in this series. I want to first have a quick agenda for everybody. We're going to talk about the series, who the partners are. We'll go through, have iBoss present, and then Atacama, and then we'll have a couple of minutes at the end for comments. We do want to thank our greater series partners who have already presented and who are to present. They've made this a great success for us. Today, again, as Jimmy noted, we're going to talk with iBoss specifically and Atacama, and what we want to do is just remind everybody about the point of Zero Trust as a standard from 2018, and much maligned and a lot of noise in the market about it. But really what we want to bring forward is that this is an operational philosophy, not necessarily a product set. And it's combining least privileged software and hardware with policy and process to make sure that when users go to work, that the only thing that they are working with is that data and those resources that they need to see. And that can be based on time of day, the machines they're using, their user ID, and so forth. If you're interested in the actual standard, it is NIST 800-207, and you can look it up online and get all the details that you would ever want to know. We want to just show that we are focusing on a couple of elements of a greater strategy today. And you can see we have a braid, and our concept here is that there's multiple strings that make a cord strong. And rather than having single-stranded solutions for cybersecurity, what we're advocating is that we begin using multiple layers of security for defense in depth and defense across the spectrum of different techs. And today we'll talk about encryption with Atacama, and we're going to talk about data packet payload visibility with iBoss. iBoss plays in identity access management. They play in unusual user behaviors in a number of places, but today we're going to focus on encryption and in how that data, what iBoss is doing with that data when it comes into their portal. So without any further ado, I'd like to go ahead and introduce the iBoss team. Jackie Campbell's the National Channel Manager Distribution, and we have Scott Gordon, who's the Cloud Security Architect. And that being said, I am going to go ahead and hand this over to Scott so that he can begin giving you guys some information that you can use. Scott, take it away.
Wonderful. Thanks so much, Jerry. I appreciate that. So yeah, that's a good intro and a good start. So one of the key things Jerry mentioned is that Zero Trust is something that is often misunderstood. I do a whole lot of presenting and discussions in trade shows and panelist discussions like this one. And for your customers, they're getting tons and tons of noise, and every single vendor in the security industry is sticking their hand up and saying, we do zero trust, we do it too. And you know what? I'm another one of those. I'm saying that, yeah, my boss does zero trust as well. But what I want to do is kind of take this quick step back and identify what the real definition for it is, how NIST defines zero trust. And then I want to show you what it means to iBoss and how we really differentiate ourselves in the market and what you can present and discuss with your customers in enabling their zero trust journey. So one of the key things that's important to understand is why everybody is moving this direction, and why customers are kind of being somewhat forced into a zero trust model. And the whole reason is everybody's moving to an adopted enterprise architecture where we're moving to a cloud first journey. That's nothing that's new. But what that's done is introduce this huge proliferation of cloud applications, because now we have remote and mobile users that are on all kinds of BYOD devices and company-owned devices coming from everywhere. That decentralized model isn't anything new, but COVID absolutely accelerated that. And what our customers and security operators are forced with is at the same time trying to protect all these remote users and migrate their internal applications to IaaS workloads. And then the same security stack requirements still apply, having to reduce the risk of not only external threats, but now internal threats as well, always preventing unauthorized access. So if you look at the SASE analysis of recent data breaches, they all relate to unauthorized network access. Somebody got a hold of a corporate laptop or accessed a network they weren't supposed to. So this is where zero trust really comes into play, because not only are we preventing unauthorized access with this framework, but stopping things like ransomware or data destruction, crypto locker malware, those kinds of things, and eliminating data loss by being able to identify when a user is touching data, again, whether they are remote at home or in the data center or in a Starbucks, doesn't matter. They should have access to the data they need and not be able to touch the stuff that they shouldn't have access to. So all of these components kind of pull together into a framework that is pushing our customers toward a zero trust based architecture. So let's make sure we're all kind of on the same page with regards to this. So the nice thing is we have a NIST definition and a standard for what zero trust is, but some of the key principles here that we've got to identify all of the users. We need to know where our resources are, what our sensitive data is. We can't protect things we don't know about. So being able to have that kind of shadow IT discovery and resource discovery, finding out what the network traffic flows are, those things are important. So being able to provide that visibility is huge for your customers. Likewise, once we can identify what it is that we're protecting, we need to funnel all users through a common enforcement point so that we've got full access control, so that we can enforce concepts like least privileged access and multi-factor authentication. These aren't new things. We've been doing this for a long time. That's easy stuff. The big difference, though, is doing zero trust architecture, ZTA, versus a VPN. So let me real quickly touch on that for a quick second. So think about your home security at your house. A VPN is going to determine who's allowed in the front door, like a contractor that's coming to work on your kitchen. A VPN is going to say, yes, that user can come in the front door, but then that's it. There's no control over east-west traffic past the VPN. You've got to have another tool in place to control that. The contractor then comes in your house and is allowed to go anywhere that they want. Contrasting that to a zero trust architecture where you're actually creating a perimeter of one. You're not connecting networks together. You're providing access for a user to touch a resource. So that contractor is not only allowed in the front door, but then you escort them all the way through the house so that they're only allowed to touch the backsplash in the kitchen. They're not going into the master bedroom and opening up drawers. That's the big difference between these two, is that the inherent security that comes with zero trust is significantly elevated over what a VPN would do. And that's important because that third bullet point there, endpoints are not trusted. There is malware, there are malicious users, there's unauthorized access. So we've got to be able to lock those things down. And that's what zero trust really does. In conjunction, it provides full visibility and inline monitoring and real-time threat detection so that we can automatically respond to threats or a user that's touching something they shouldn't, or trying to download a file that they shouldn't, or exfiltrate data. This is really what the basis of zero trust is. And the NIST architecture is literally this. It is very, very simple. And I call these big dumb animal pictures, just a very easy way to describe to your customers what the NIST architecture is that there is a subject or a user on an asset that is accessing a resource, and that's it. That resource could be the open internet, it could be a SaaS application, it could be an internal app that the customer is hosting in the cloud or in their private data center. Doesn't make any difference. Whenever there's a subject or an IoT device or an API call accessing a resource, we need to have in the middle a policy enforcement point. And that's probably the new term when it comes to the NIST standard, is the idea of this policy enforcement point. And that is a binary checkpoint that is brokering the connection for the user and is making a decision to determine whether that connection should proceed or whether it should be blocked based on policy. And again, these are very simple things, but when we look at the architecture kind of expanding on this a little bit, NIST also defines two more components that you see in here: the concept of an untrusted zone, which could be the user just sitting on the internet or their untrusted home network. And then once they go through that policy enforcement point or that policy decision point, then they are in the implicit trust zone, where security is implied and their connection is secure. Well, this is a big component of the NIST architecture, because what we don't want to do is have that implicit trust zone be a large area or a huge network like the open internet. We want to have the surface area of that implicit trust zone be as narrow and as slim as possible. And that's part of the differentiation of what iBoss does and what we do differently. So iBoss is that policy enforcement point. We are a cloud-based architecture that allows you to securely connect users on any device in any location to connect to any resource. And while we're connecting them to that resource, we're opening up the SSL session and enforcing full security policy. So Jerry mentioned earlier that we're going to talk a little bit about Secure Access Service Edge. And just to get in your minds, the difference is that zero trust is what we're trying to accomplish. We're trying to accomplish a framework of zero trust using multiple technologies. Secure Access Service Edge is the how we're going to do that, because in my opinion, the most efficient way to accomplish the most zero trust objectives is using a Secure Access Service Edge platform. We all agree, though, that zero trust is not a product. It's not something you can buy off the shelf, but you can knock down a whole lot of dominoes at once by deploying an architecture like this. And so let me tell you real quickly kind of about this architecture, and then I want to get into some key differentiators that you can communicate to your customers as well. So like I mentioned earlier, we're securely connecting any user on any device to any resource. That resource could be a SaaS application, it could be the open internet, or it could be an internal application that sits in the customer's public cloud like Azure AWS, or it could sit in their own private data center. Doesn't make any difference. Remote users need to get to their applications, to get to their resources to do work. While we're connecting those users to those resources, we're opening up their session and applying this full security stack on the left-hand side. And this is the traditional Secure Access Service Edge architecture. What's very different about iBoss and what we do is several things. First of all, this is what we call a single unified edge, meaning there's one iBoss platform that performs all the capability that you see on the left-hand side. There's one console, there's one dashboard, there's one single pane of glass for all of this capability. Contrasting that to some of our competitors that have one cloud for internet access, a different cloud for private access, maybe even a third console for managing the agents on endpoint devices. That is way too much overhead for our customers, and it gets very complicated from an operational perspective. Likewise, in some architectures, there's a big difference between the capabilities of those multiple clouds, meaning for internet access, yeah, we'll go ahead and do malware inspection and DLP, but for private access, there's no inspection at all. That doesn't make a whole lot of sense. We need to be able to still do malware inspection and DLP, even for internal resources. And that's why this architecture, the IBOS single unified edge, is so important, is because all the capability applies, meaning proxy and DLP and CASB rules and malware protection, all of that is in place regardless of what device the user is connecting with and what resource they're accessing. So that's one big differentiator. There's a single unified edge, one IBOS platform. Another big differentiator are these blue cubes on the right-hand side. These are what we call containerized gateways. These are the policy enforcement points that we saw in the architecture before. And the key thing here is that every customer gets their own dedicated IBOS cloud with their own dedicated policy enforcement points. So the architecture kind of looks like this on the left-hand side here. So customer A has their own dedicated IBOS cloud with their own policy enforcement points that are dedicated to them. Those are completely separate from customer B, who has their own dedicated IBOS cloud as well and their own PEPs. Contrasting that to the architecture on the right-hand side, which is every other SASE platform. You name them, this is exactly how anybody else does it, and why IBOS is so different is that the architecture on the right-hand side here, everybody's going through a large common shared gateway. And so you'll see strange things like customer A will be served a block page from customer B's configuration, or different things like that that are kind of uncommon, but they can happen because the decryption keys for all of those sessions have to sit in a large shared database in that gateway. So what is very different about the IBOS architecture on the left is that we provide much better connectivity because the users have a dedicated policy enforcement point that they're going through that's dedicated to that customer. Likewise, the security is significantly improved because all of the decryption keys are kept completely private. So if you have customers that have GRC requirements or audit requirements, we've got a lot of capability around keeping the data completely separate and segregated. And then third, one of the nice pull-through effects of this architecture is that each of these gateways has their own dedicated IP address. So if your customer needed to write an IP-based ACL, something like that, to connect to an extranet partner, or to privatize even their public cloud infrastructure like Azure or Office 365 or Okta. Let's say we want to lock that down so that only users coming from my dedicated IBOS cloud are allowed to access my O365 environment. You can absolutely do that because every customer has their own dedicated IP addressing, as opposed to the architecture on the right where you're egressing that platform from a giant shared block of IPs that could be even blacklisted by Google or something like that. So it gives customers all the same visibility and control that they would have with an on-premise architecture, but leverages the cloud for scalability and flexibility to deploy the solution. So back to the zero trust architecture, we mentioned that there are three main definitions or components to it. You've got the identification of resources, you've got subjects, assets, and the policy enforcement points, those four components. So let me show you real quickly kind of what the IBOS console looks like. I've just taken some screenshots here so that we can do this a little bit quickly. But in the zero trust policy manager here, you can see across the top, all the capabilities of IBOS are all in one place. I'm not jumping over to different consoles for private access versus internet access. Everything's in one place. We're decrypting a packet one time, and we're enforcing security policy on it. But you can see here is my resource database. And these are both external applications like Jira or Box or Confluence or GitHub. They can also be internal resources like a privileged router or maybe a DB2 server that my admins have to get access to. So we can define all of these resources and leverage shadow IT discovery to determine what resources are in play. And then we want to write resource policies. So policies can group together multiple resources to say, like, for instance, at the very top here, I have a policy for my DevOps applications. This might be Jira, Confluence, and GitHub. And I'm going to grant access for my DevOps team to access those applications. And I want to enforce some specific security controls. Maybe I want to apply DLP specifically to GitHub and make sure that they're not posting our intellectual property and secret code into a shared database. Likewise, I might write a policy for internal legacy applications. If I've got an internal database or server, something like that, and write a policy for who's allowed to access those. And then we need to be able to provide visibility and reporting. So understanding what devices are connecting to the platform, what the asset posture is of that device, what revision they're on, and providing full visibility into every single transaction that goes through the platform so that we know exactly who's accessing what, why they were blocked, why they were allowed, what URLs they're accessing, what policies they're hitting. This gives your customer all the flexibility and visibility that they need to actually accomplish their zero trust goals. But all of that being said, technology is really cool, but that is never what drives a purchasing decision in our world. So we've got to have real world business drivers for why a customer is going to move to a zero trust architecture and deliver on their business goals. And so these are some key ones that I hear from my customers that you all are welcome to use in driving business cases with your customers. First of all, my existing customers are significantly reducing their risk and improving their security posture because they're able to stop ransomware and unauthorized access and prevent data loss using a platform like this. They're able to adopt a true cloud-first strategy and get out of the hardware appliance data center mode of doing heavy networking, leverage the cloud for flexibility. And a lot of times what that does is we can eliminate the need for a VPN. Nobody loves connecting to their VPN. And so this is the much more modern way of providing access to internal resources. And a lot of customers are able to completely get out of the game of doing on-premise hardware refreshes and worrying about data center and power and IP addressing, move everything to the cloud and truly take advantage of remote workforce flexibility. A lot of my customers are looking at their capital and physical building requirements and saying, my goodness, we may never need to come back into the office again. Think of what that does for the business when you can truly reevaluate your physical building requirements and say, all right, maybe we don't need to spend all these capital dollars on building infrastructure. We can reinvest that back into the business. So just a couple of quick examples of real business outcomes for moving to this architecture. So I'm going to throw over to my Atacama peers. We're going to talk about data protection and encryption, but let me take a quick break there and see if there are any questions we want to address in the chat.
Thank you, Scott. There is actually 3 questions that came through. What does the user experience look like to connect to internal application? Do they have to launch another agent?
Yeah, that's a good question. The nice thing is that it's very simple. It's not like a VPN. The user simply connects and all their applications are available online. So if they need to get to a website, if they need to get to O365, if they need to access an internal database server or a file share that's sitting in a data center, doesn't make any difference. Their applications are just simply online. They don't have to do anything else or click on anything or launch another client.
The second question is, I have a customer who needs to allow external contractors to upload invoices to an internal application. They want the files scanned for malware before they land on the internal application. Is this something iBoss can do?
Yes, definitely. That's a good use case. So I've got external contractors that are needing to upload something like an invoice, or I did this with a port authority where they needed to upload shipping manifests. But I don't want that stuff landing on an internal server without being scanned for malware first. Yes, remember I mentioned earlier about the single unified edge, that we're doing malware and DLP scanning regardless of whether that user is coming from an external BYOD endpoint or an internal company-owned device. If it's going across this platform to access an internal resource, yes, we can definitely still scan that for malware. Good use case.
Great. And the last question is, how is this priced? Are there additional bandwidth charges for high usage?
Thanks. I actually forgot to mention that. So the platform is simply priced per user. But because of that architecture that we talked about, where every customer gets their own dedicated iBoss cloud and their own gateways, we don't need to charge additional funds for bandwidth or tunnels or anything like that. That gateway is dedicated to that customer. So if they need to build multiple tunnels to it or enable exact data matching that's very CPU intensive, go right ahead. There's no limit to the size of files that can be scanned. We're not limited to 100 megabyte files like the architecture on the right here would do, because you're going to affect the performance of every other customer going through that shared gateway. With the iBoss architecture here on the left, the customer controls exactly the size of files that they're going to be scanned, what's going to be scanned, and they can build as many tunnels as they need, and there's no extra charge for bandwidth for that reason.
Perfect.
All right.
Thank you. That concludes the questions for iBoss.
Wonderful. Let me send the presentation over to Stephanie. We'll kick it over to Atacama. Thank you all very much.
And I'll take a second here. I'd like to introduce the Atacama team to our audience. Today we have three representatives from the company. We have Stephanie Weigel, who will be doing the initial presentation. We have Rich McGrath, who's Director of Channels, and Jeremy Billfeld, who is Director of Marketing. So if you guys have questions out there, this is going to be a great audience to pose them to. So without any further ado, I'll go ahead and hand it over to Stephanie.
Great, thank you. I'm actually going to leave it to Rich to do some very quick introductions, and then I'll jump into the meat of the presentation.
Thanks, Steph, and thanks everyone for joining. Thanks to the Ingram team for having us. I think this is a great forum, and obviously a great topic to be discussing. So really appreciate everyone taking some time out today. So as Jerry mentioned, I'm Rich McGrath. I'm the Director of Channels, so I oversee our partnership with all of our strategic partners, distribution, reseller partners, and alliances. I just want to kind of give a quick overview of Atacama, who we are and what we do, and then of course I'll pass off to Steph for the bulk of the presentation. So you know, Atacama is a standalone encryption company that is in and of itself a bit unique, right? We oftentimes see encryption as sort of an add-on to another larger platform. And that's part of the reason why Atacama has come to be, right? We've been in business for about 6 years now. We've been selling commercially for about 3. And we're starting to see a lot of success based on some of the key differentiators in the way that we're approaching encryption. I won't steal any of Steph's thunder with some of the details, but it's really important to note, right? When we're looking at things like ransomware and the evolution of ransomware attacks into data exfiltration, and Scott touched on this a little bit as well. I think it's really important. It's something that's a huge concern today. And the way that we're approaching encryption is really going to eliminate a lot of the magnitude of some of those data exfiltration attacks, right? In the way that we're protecting the data, in the way that we're decentralizing and distributing the key architecture as well. So we're really changing the face of encryption. And I know that's a bit of a bold statement, but it's a fact. And we're changing the face of encryption, and we're doing it specific to the threat landscape, right? So we look at the threat landscape today, it's evolving at an unbelievable pace, right? And we look at some of the security solutions in the market that are have been around for a little while, right? They're not necessarily as dynamic as the threats they're aiming to protect against. So that's really where Atacama has kind of come to be, and again, addressing some of those key attack vectors that we've seen in some of the legacy encryption solutions. I also want to mention from a go-to-market standpoint, we've been a part of the Ingram Micro EBG group since the beginning of 2020. It's a great partnership with Ingram Micro. They've been a fantastic partner, and also from a strategic standpoint, we're a channel-only company. A lot of times we see conflict with channel partners and a direct sales motion. We do not have that in any way, shape, or form. We do not sell direct. We don't want to sell direct. We absolutely appreciate the channel, both from a distribution and a reseller partner standpoint. So we're 100% committed to that in terms of go-to-market. So it's really, that's really critical and important as well. We've got a robust channel program, very much focused on enablement, also focused on some strong margins for our partners as well. Yeah, with that, I just want to say thank you again. Looking forward to the follow-up, and we're happy to discuss the solution in a bit more detail, or discuss the channel program as well. But with that, I'll hand over to Stephanie.
Excellent. Thanks, Rich and Scott and Jerry and team for the warm welcome. I'd like to jump right in and discuss multi-factor encryption for zero trust security posture, and very specifically through the lens of data protection. Scott mentioned in the prior discussion that, you know, zero trust can mean a lot of different things to a lot of different people, and I certainly agree with that. He also mentioned that zero trust is a philosophy and an approach versus, you know, some kind of one-stop solution or specific technology buy. But the reality is that the zero trust journey, and it's really what it is a journey, is ever evolving with many different layers involved. And as we learned from Scott, and as NIST describes it pretty appropriately, zero trust is a cybersecurity paradigm that's focused on resource protection and the premise that trust is never granted implicitly, but must be continually evaluated. And I'm pretty sure it's well recognized, and I think it's for the exact reason that we've got folks tuning into the webinar today, and part of the Ingram series is that zero trust continues to gain traction as the strategic security approach best suited to secure today's hybrid environments and mobile workforces. So when it comes to hybrid environments and the ability to better support the work from anywhere approach, one that the pandemic, as we all know, has only accelerated, you know, remote work and increased the number of devices that each person utilizes. But at the same time, these organizations dealing with this hybrid environment, remote work, have also moved a large portion of their workloads to applications, and as a result, data now resides outside the secure network perimeter. And this isn't new, but it's only accelerated over the last few years. And following that path of data through these diverse new environments is, as you can imagine, quite complex and creates a significant challenge in the realm of cybersecurity. So, you know, and Scott also touched on this a little bit earlier on, you know, at the root of a zero trust security approach, there are several key principles to consider, and I want to walk through those briefly for a moment here. Never trust and always verify. What does this really mean? In a default trust network environment, obtaining a set of login credentials for valid users provide malicious actors with the capability to log in, you know, breach those credentials, log in, move through the network unchecked, unvalidated, and ultimately exfiltrate the sensitive data or install the ransomware on critical systems. The goal of zero trust is to mitigate those possibilities by regarding all network traffic as untrusted, full stop, whether it's in the public cloud or on-prem. Data security at the core as the second key principle. The zero trust approach means that we are flipping the script and putting data first. It enables organizations to gain back control of their data assets. We all know that data breaches continue to rise each year, and ransomware attacks evolve in frequency and sophistication, and all of us on the line here today are far too familiar with the various extortion tactics that are holding companies hostage. So existing controls, legacy strategies are not properly protecting these critical business assets. And again, we're thinking about this from the data, the file level. And by knowing where all your data is and authenticating every time a user tries to access that data, you ultimately enable a shift to this data security centric model. The third pillar being robust authentication really ensures that users and devices are who they say they are. We just spoke about always verifying, and this is one of the basic principles of zero trust. Whenever and wherever a user tries to access files, applications, or various cloud storage services, you must be able to authenticate those requests using IP addresses, usernames, passwords to authenticate is no longer as sufficient as it needs to be in today's complex IT environments. The next principle here to review is around least privilege enforcement. So zero trust strives to enforce least privilege access by accounting for who is making the access request, the context of that specific request, and the level of risk that that request holds. By enforcing this least privilege access, you can minimize or shrink the attack surface, limit that lateral movement of the attacker in the environment, and ultimately reduce the chances of those malicious actors getting in and accessing the most sensitive data assets. You're really eliminating the risk of excessive access to your critical services or data through this principle. And finally on the list, but certainly a significant contributor to a zero trust posture, is the monitoring and logging. So providing a new level of visibility that facilitates adaptive policy decisions based on a user and their trust score. Instead of traditional binary policy deciding what a user can or can't do based on their role and their profile, the logging and monitoring brings more cybersecurity intelligence and transparency into the equation. And in the zero trust framework, this increased intelligence and transparency is not limited to the user actions, but it also includes the devices and applications and what they are doing on the network. So what does this all mean in practice? And again, through the lens, very specific lens of data protection, we view the data as the most critical component of the environment. And as we said before, data really becomes the component that must be addressed by a zero trust security posture specifically. And again, zero trust as a layered approach, complementary to the various solutions that are out there. But in order to achieve zero trust at the file and data asset level, we look at 4 critical components. The first of those being identifying sensitive data. So sensitive data is, as we've discussed, a critical target in the cyber attack surface for every organization. Part of the reason that the zero trust implementation can feel overwhelming or feels like a complex undertaking is that in some cases organizations are trying to implement policies and secure everything all at once. It's far more sufficient and effective to begin the process at the file level by identifying what are those most valuable data assets. Often those critical assets are files and include information like trade secrets and intellectual property, PHI, PII, and other critically important data. So the first step is to identify what that is. Second is creating policies and limiting access. So with this sensitive data and other valuable assets identified, you can start to create a zero trust policy and limit access that are in line with those 5 key principles that we've already discussed. In order to approach this and achieve this level of zero trust in this scenario, it's important to think about decoupling access verification from identity and access management. And we'll dig into that a little bit more deeply in a moment. But the reason that you don't want to rely solely on identity and access management as a single source of truth for verifying access to a specific file, to a specific critical data asset, is that stolen identity, which we are aware happens regularly, absolutely compromises those zero trust efforts when you're looking at it from the file level perspective. So the next step in the process would be to begin with the file level encryption. So this is a natural starting point for the zero trust implementation. Once the sensitive data is identified and located and the policies are created, then you need to limit access to only those who strictly require that access. The file level encryption provides really a practical way to protect those sensitive data assets and ensure that they're only accessible to authorized users only. The final point here is detecting threats, and knowing what's going on in your network environment and on the endpoints is certainly vital for flagging anomalies in how data is being accessed and what those users are doing. So there are several different security tools that can help gather that intelligence or detect threats, and there's a good chance today that your customers are already taking advantage of some of those in their environment. So we've focused on the foundational groundwork for zero trust at the file level, and you might be thinking about conventional encryption solutions and about how identity and access management plays a role and provides perhaps a reasonable approach to protecting files according to the zero trust principles and the ability to lock down that data. But in this modern environment that we've discussed, the conventional encryption solutions are really no longer capable of protecting those critical files in the face of a cyber attack and explicitly the data exfiltration component of that attack. The legacy encryption solutions are inherently tied to identity and access management controls. And as we know, there's a very important role for identity and access management, and they store the user's identity and profile information and their data governance functions, and that absolutely needs to be in place. But too often, organizations are overly reliant on the passwords and the multi-factor authentication to defeat that data exfiltration component. But the inherent problem in this scenario is that, as we know, passwords are often cracked and broken, via, gosh, the list is endless: brute force attacks, credential stuffing, phishing schemes. The list can go on forever. But with the file level encryption that is disconnected from identity and access management, even if someone is able to compromise those credentials and breach the network, individual files remain inaccessible. So this is where, we're looking at a new approach from an encryption perspective, and we're looking at distributed key management for multi-factor encryption as it becomes really the cornerstone of a zero trust journey at the file level. So with Atacama, you're able to encrypt files effortlessly, whether they're in the cloud or on-prem, and ensuring that that file access is truly limited to authorized users only. Not threat actors masked as authorized users after breaking credentials. Where the rubber meets the road is the distributed approach that Atacama introduces to eliminate that data exfiltration threat. And the way that that's achieved is with Atacama, each file is automatically encrypted using AES 256-bit key. The unique key for each file is then automatically fragmented into key shards. So we're taking that encryption key, breaking it into disparate pieces, and distributing those pieces across physical devices. The decryption of the file is facilitated in a couple of ways. Most commonly, and how many of Atacama's customers are decrypting today, is through the power of their mobile device. The decryption occurs seamlessly with the user clicking on a file to access that file and open that file, and then receiving a notification on their mobile device. Once that notification is a request on the mobile device to provide the relevant key shard to reconstitute that encryption key to decrypt the actual file. So remember, we're not talking about one encryption key. Well, we are talking about one encryption key, but that encryption key is broken into multiple pieces. In order to access that file and open that file, you must have the disparate pieces to actually reconstitute that key and gain access. Alternatively, there's the Atacama key shard server that maximizes maximizes that same level of file security, but for use cases that are centered around automation and batch file processing, and in scenarios where you have, the mobile device and the key shard server, user workflows are maintained, and it remains a seamless user experience. So in accordance with company policies, when utilizing Atacama, every request is evaluated individually in alignment with the zero trust principles of enforcing least privileged contextual access. So what we mean by that is the multi-factor aspect of multi-factor encryption, as you can imagine, derives its inspiration from a concept that I think we're all familiar with, both in our professional lives as well as our personal lives, but multi-factor authentication, MFA. And this is the approach in which users need to provide at least 2 distinct pieces of evidence that prove they are who they say they are before being granted access to a system. In multi-factor encryption, 2 devices at minimum are needed to open that encrypted file. And the similarities, compared to MFA end here. As multi-factor encryption always keeps data protected, well, the MFA, while important, is focused on strengthening the logins against credential compromise, but don't focus on protecting the sensitive data that ultimately are, that sensitive data is what the adversaries are looking to gain control of and exfiltrate. This approach utilizes a decentralized architecture with no dependence on identity and access management, removing the threat of file exfiltration in the event of compromised passwords. And this approach also it eliminates the reliance on central key servers as well, because as we described previously, we're not storing singular keys in a encryption key store or a central server. We're breaking that key into multiple pieces and requiring putting that key back together in order to access the file. So it eliminates a central key store as a single point of failure as compared to traditional encryption solutions on the market. So how does multi-factor encryption eliminate file exfiltration and really support the zero trust approach to protecting data at rest? Scott mentioned it. I think we're all very well familiar. The attacks, ransomware, doxware, exfiltration, extortion, whatever it is, whatever day of the week it is, whatever it's called. At the end of the day, the end result is unauthorized third parties gaining access to the company's data. These attacks have evolved over time, from locking up data to actually stealing the customer files with the threat of exposing that sensitive information or data on the dark web. And Atacama's multi-factor file level encryption mitigates this worst case scenario of the file exfiltration itself. With the multi-factor approach to decrypting files, the only time a file is actually decrypted is when the user opens the file locally. Atacama files are always client-side encrypted, so it's always the encrypted version of the file that lives in the cloud or on the server, and therefore you don't have to rely on the network security alone or the cloud provider's environment to protect those files. Atacama ensures that those files remain encrypted even when the cloud or network environment becomes breached. So we've discussed the philosophy of zero trust, what that means from an encryption standpoint, how multi-factor encryption is differentiated to enable a zero trust security posture. So now I'd like to kind of dig into some of the meaningful use cases that some of your customers may have going on in their respective environments. So locking down sensitive data, we've talked about this at length. The ability to easily encrypt mission critical files without disruption to existing user workflows. This could be, again, PII, PHI, IP, trade secrets, any mission critical file level document that is lost or stolen that would be detrimental to your business. This is the level of data that we're talking about and the level of protection that we're talking about. Anytime you hear about these conversations, this is a project 100% suitable for multi-factor file encryption. As you can imagine, this concept of locking down sensitive data also falls into larger, more comprehensive initiatives, some of those being around data protection, data privacy, and data governance projects. The ability to eliminate file exfiltration. Really, I can't think of any other business outcome other than the ability to completely eliminate file exfiltration. Even when user credentials are hacked and, quote unquote, authorized users have access to these files, Atacama is providing that true last line of defense that ensures content of the protected files cannot be decrypted. So the projects here are folks that are, unfortunately reacting to some kind of event that they've had in their environment, or potentially seeking innovative solutions to better protect themselves from data exfiltration events that are on the horizon. Another extremely relevant use case, and one that we haven't touched on quite yet, is around compliance. So if your customers are dealing with new or existing compliance mandates, Atacama plays a very significant role here. Whether it's working toward compliance for HIPAA, GDPR, NACHA, CCPA, name your 4 or 5 letter acronym in the regulatory compliance space, the multi-factor encryption capabilities really support locking down data according to those various compliance mandates focused on protecting data at rest. We touched on this already, but important to emphasize a little bit more here is around cloud security. So the files, again, are always client-side encrypted. So it's always the encrypted version of the file living in the cloud, living on the server. So for organizations that are looking to strengthen the security, in addition to the native basic security provided by the cloud environment, Atacama ensures that the files, again, remain encrypted even when the cloud or network environment has been breached. Another common and quite compelling use case is around secure file transfer, or the sharing of a file outside of the organization while ensuring complete protection. Atacama's secure file transfer capability, what it does is enables the secure sharing of that sensitive data that with users outside of the organization and with users that may not have Atacama in place within their environment. The solution generates a download link that's shared with the recipient, and the sender remains in complete control of the decryption itself, with the added benefit of being able to verify the recipient's identity before the file is downloaded. So you're capturing that highest level of security at the file level and maintaining that through the transfer of the file to the end user. So very significant use case. And then finally, data discovery and classification. I look at it as multi-factor encryption is a very close cousin or even a sibling to the data discovery and classification universe. And this is through the seamless integration with various data classification tools. Atacama actually, encrypts the files according to the policies that are defined by the data classification tools. And I think it's worth digging into this briefly here for a moment. The accuracy of data classification and identification tools really allow the organizations to leverage protection that's optimized for the sensitivity of the data. If we remember back earlier in the conversation when we talked about identifying where that data is, applying the controls around who has access to that data, this is where the integration, the seamless integration with the data discovery and classification tools and Atacama comes into play. So it really becomes a scenario where it's discover the data, classify the data, and ultimately protect the data with the most secure and highest levels of protection to prevent that data exfiltration that we've talked about at length. So with that, it was a lot of content in a short amount of time, and I appreciate the time that we've all spent. And with that, I will throw it back over to the Ingram team.
Thank you,
Stephanie.
Stephanie. I'm going
go
to
ahead,
see
Kelly.
if there's a question. There is actually 3 questions. First question is, how does segregating IAM from cybersecurity provide a solution for users who should not have access to classified or encrypted data?
Thanks. I can take this one. So IAM, as Stephanie mentioned earlier, is a critical component to the security stack, right? But segregating the security at the object level creates a secondary layer of defense for the sensitive data and really the crown jewels. You know, we actually put out a white paper that goes into this a little bit further, but making sure that even after users have breached credentials, they don't have access to all of the sensitive data at wholesale. So by introducing that secondary layer of defense, by encrypting each file with its own unique encryption key, that really creates a whole new level of security.
Thank you. How does the solution address concerns around the zero trust framework for cloud security?
Yeah, I think we touched on this as well. So Atacama itself integrates with all major cloud providers, Dropbox, Box, OneDrive, where, you know, we enable organizations to continue to utilize the benefits of storing their data in the cloud, but without having to rely on the native security of that cloud provider. And the reason is because Atacama, by using Atacama, organizations store only the encrypted version of those files in the cloud. So even after, you know, their instance perhaps gets attacked and compromised, they would no longer have any access to any of the actual sensitive data, only the encrypted versions that are stored in the cloud.
Great. And we have one more question. Doesn't splitting keys result in excessive key management overhead?
Actually, we argued the opposite. So Atacama, you know, a traditional key management server distributes keys and rotates keys based on permissions. And the way that Atacama software works, it automatically distributes keys for each individual file based on only the approved user's access to those files. So if anything, it actually really significantly decreases the overhead of the key management by automatically or semi-automatically distributing keys for each file.
Thank you. That concludes all of the questions that we have.
Well, I want to thank everyone. I'm sorry, go ahead, Jimmy.
I was just going to say thank you, Kelly, for the questions. And I want to thank each of our vendor partners, iBoss and Atacama, for being here. And thanks to you, all of our solution providers, for attending. We will follow up with the communication with links to our vendor partners. Jerry, over to you.
Okay, thank you, sir. And you know, we we're almost out of time. Actually, we are. Any further questions? Please feel free to send some email to us, Jimmy or myself, and we will get those questions to the right people and follow up with answers for everybody. I do want to just do one more thing and just plug our next session, which is on August 9th. Where we will talk about operational technology and industrial control systems, and we will have our vendor partner OpSWAT join us for that. The OpSWAT will be the only presenter on that session because of the depth and breadth of these subjects. There's a lot of demand for information, so we wanted to be sure that we didn't sell our partner short. We want to be sure you all get the right information and have opportunity to ask a lot of questions. So with that, I am going to turn it back over to Kelly as Master of Ceremonies, and we can close this out.
Thank you, everyone, for joining. This session has been recorded. A recording will be sent out to you. And we thank you guys all for your attendance today. And that concludes our webinar.
Thank you, everybody.